Hi all, welcome to Clear and Concise. Let's have a look at this question. The longitudinal stress is 100 megapascals in a long thin cylinder vessel closed at both ends that is subjected to internal pressure P. Let's assume internal pressure is P. The corresponding hoop stress is, we need to find the hoop stress sigma H. They have given longitudinal stress sigma L. Okay, now let's see what is mean by thin cylinder. We say some cylinder as thin cylinder when the ratio of diameter to thickness is greater than 20. Greater than 20. This is mean diameter of the cylinder and T is thickness of the cylinder. When the ratio is greater than or equals to 20, we call it as thin cylindrical vessel. Now let's consider a cylinder which is subjected to internal pressure. If we take the sectional view as shown here in the figure, we will be having longitudinal stress sigma L acting on the sectional view as shown here along the circumference of the section. Now the internal pressure, the fluid exerts the internal pressure on the other side of the vessel, that is closed side. The pressure is P. Now applying force balance, it is sigma L times the cross sectional area, that is pi d times thickness. Pi d is circumference and T is thickness here. D is mean diameter, that is equals to internal pressure P times the area, that is pi d square by 4. Here pi d gets cancelled. We will be having sigma L times T equals to PD by 4, which yields sigma L longitudinal stress is equals to PD by 4T. PD by 4T. This is longitudinal stress. Now let's find the hoop stresses that are acting on the thin cylindrical vessel. Let's consider this diagram shown here. The internal pressure in the cylindrical vessel pushes the ring uniformly outwards. Because of this, there will be a circumferential stress along the ring. Let's consider the sectional view of the cylinder as shown here in the figure. The internal pressure acts on this area, that is rectangular area, uniformly throughout the cylinder. So let's assume this area is L times D. So throughout this projected area, that is projected area, there will be a internal pressure acting in the cylinder which pushes the ring outwards. Because of this, there will be a internal circumferential stress, that is sigma H, which acts tangential to the ring as shown here in the figure. It acts on the circumference, that is on this area, both this side. So this area is, circumferential area is L times T, where L is length of the cylinder and T is thickness. Now writing the force balance equations, internal pressure P times area, that is projected area, D into L is equals to sigma H, that is hoop stress or circumferential stress, times, we have two sections each other side, like so 2 into length times thickness. Now here L gets cancelled. Sigma H is equals to PD by 2T, where T is thickness of the cylinder and D is mean diameter. Earlier we have seen that longitudinal stress is PD by 4T. Therefore, sigma L is equals to sigma H by 2. But here we have been given longitudinal stress, that is 100 megapascals. So sigma H is equals to 2 into sigma L, that is equals to 2 into 100. So 200 megapascals. The correct answer is option C, 200 megapascals.